have another question that has to do with the change in volume of two substances or two compounds, so to say, water and ice. Water and ice. We must calculate the change. Calculate the change in volume. Change in volume. When 90 grams of ice is totally, another word for totally is completely melted. Alright? Of course, it's going to melt from solid state to what? Liquid state. So we have two volumes. Volume of the ice before it melted, and then volume of the water after it has been melted, or after it's melted. Alright? So let's go into that. So the first thing we need to do here is we start with identifying our perimeters, so to say. Alright? So let's look at it. Density of water. Let's identify the parameter here. Is the first one is data. The first one here is density of water. I'm going to use rho. This symbol stands for rho. It's a Greek word used in science for representing something like density, conductivity, and the rest of them. So density of water is given as this. Alright, water density is given as this. I don't know. Okay? Alright, and this is 1 grams per centimeter cube. Alright, that's for water. Okay? Then density of ice. Density of ice is 0.9 grams. Density of ice, that is rho, is equal to, I'm just trying to identify this the way we're going to understand it, is 0.9 grams per centimeter cube. Alright, so these are the things we need to know. Then the next one is we need to find the density of ice. We need to find the volume of ice using its density, okay? And also we need to find the volume of what? Water using its density and mass given, alright? A particular mass is given. So we have the third one. The third one, I, is mass. N is given as 90 grams. Yes, 90 grams. That is this, 90 grams, okay? So with this, we can find the volume of the ice before it melted. That's the first one. We can also find the volume of water after the ice has been melted, okay? So let's take that, or has melted, okay? Let's take that. Volume of ice first. Volume of the ice. That's the first thing, of the ice, is given as V ice is equal to density ice all over what? What's the volume? Because density is mass over volume, so what should happen here? What should happen here? Look at it. It should be density over what? Mass. Alright? Mass is general. Okay? Let's check. Don't worry. Okay? Let's check the formula we're going to use. Let's cross-check something if it works. Of course, I know that density, first of all. Why am I having problem with this? Okay. There's no problem. Let's check this. Density is given as mass over volume, okay? If we're looking for volume, it should be volume is equal to mass, yes, all over density. Good. It's this way. So we have this. We can call this mass, this is relation 1, or relation 2, this is relation 1, okay? The original formula is density is equal to mass over volume. Good. So that's the first thing we need to know. Please, I want to apologize here. The voices you are hearing in the background are the voices of students, okay? Yeah, because I am in a school environment doing this. So please bear with me. Okay, now we need to find that for eyes. If we say this volume is for eyes, this density is for eyes. So for eyes we have the mass remains 90, okay? Good. The mass of the substance is 90 grams. So mass 90 over density of ice, and density of ice is 0.9. That's what we have here. If we simplify further, we will now see that this becomes 90 all over 9 all over 10, and this is going to be a very simple thing. I am doing this so that you know how we arrive at the answer. This becomes 90, okay, times 10 all over 9. So let's see, that's 900. 90 times 10 is 900. Divide by 10 is 100 each. Good, so we have equal to, we have everything here boils down to 100. Why am I having this issue with chalk? Okay, this becomes 100 cm cube. Alright, because we are talking about volume. Volume of the ice. Okay, volume of the ice is 100. So we write for VIs, we have 100 cm cube, right? 100 centimeter cube, okay? Now let's look at finding the volume of water, because the ice has melted into water now. So the next thing we're going to find is the volume of water after the ice has melted, okay? So we look at volume of water, and it's going to be VW. VW is equal to mass over density of water. And quickly, mass is 90 as usual. Density of water is simply 1. Good. That's what we have. Density of water. Water density is 1 grams per centimeter cube. Yes. So we go. Eventually it's going to be, therefore, VW volume of water is equal to 90 cm cube. So nothing changes here. Okay? Good. But we are not done yet. The question says the change. Look at this. The change. Okay? The change in volume. The change in volume. That's the question. Not just find the volume. They say the change in volume. That means the difference in volume. When you have it as ice, it has its own volume. When you have it as water, it has its own volume. What is the difference between these two volumes? That's what I want to find. That is what I want you to find as a student, writing an exam that contains this kind of question. So what do? Change in volume. Change in volume. In volume, all right, is given as this. This is change in volume. So for us to find change in volume, we simplify the difference. Change in volume, delta V is equal to maybe V water minus V ice. Quite interesting, right? Or V ice. Okay, it was first of all ice before melting into water. So we start with V ice, and then V water. Yes. It was first of all in solid state, and that's the ice form. Then it now melted into water. Good. So we then have, for ice, we have 100. For water, we have 90. And eventually, what is the answer here is just simply 10 cm cube. That's the answer here. That's the final solution here, because we have found the difference. Difference between the volume of ice and the volume of water is simply 100 minus 90, and the remainder is just 10 cm cube. All right, so we have successfully found the change in volume when it melted from ice into what? Water. That's it. Take notes. However, if the steps are not clear, maybe you are finding it difficult, put it in the comment section, all right? Give me some time, so don't forget. Share with your network if you are satisfied with it, or if this resonates with you, share with your students, share with your network, and then give me some likes. Don't forget to give me comments. Comment very important, because with your comment I will know whether the video is actually hitting the targets in terms of the impact. I want to know the impact rate. Is it good? Is it not good? And so on and so forth. These are things I want to hear from you. I want to know. I can't judge myself. It is you, my learners, my viewers, that will say, oh, do this, change this, put this, add this. This is okay. This is not okay. Thank you very much. I am signing up now to prepare for another class.